Hey guys, Mr. Backerberg here. In this video, we're going to look at the average value of a function. So if we think about what that word average really means, the average of n numbers is the sum of those numbers divided by n, or the number of numbers that we added together. So how could we define the average value of an arbitrary function f over a closed interval from a to b? Well, since there are infinitely many values along that function to consider, simply adding them together and then dividing by infinity, that's not really an option. So instead of looking at every single value along our function, we're going to take a sample of n numbers from regular subintervals on the interval a to b. So what we're going to do is let c sub k represent some x value along our function on that interval from a to b. Now, to figure out how far apart these c values that we're going to be finding are, we're going to find the change in our x value, or our delta x value. If we think about equally spacing these along this a to b interval, then what we would want to do is take that b value, subtract the a value, and then divide by the number of subintervals we want to create. Now, if we were looking at actually doing the averaging, what we would want to do is find the function value at our first c value, then add on the function value at our second c value, and we're going to keep adding these function values together until we get all the way out to that nth c value. And then what we would do is we would take all of that and divide it by however many numbers we were adding together. Now, if we do just a little bit of manipulation with this divided by n, we could really write that as 1 over n times all of these different function values being added together. But then if we think about actually adding all of those function values together, since we're adding a whole bunch of things together, we can write that in our summation notation using that Greek letter sigma. Now we're starting at a k value of 1, and we're going out to n subintervals here, and we're adding all of these function values at our specific c values. Now there's one more slight change that I want to make in here, and I'm looking at that 1 over n. If I go back to how I found my delta x values, that was our b minus a over n. I'm actually going to take this b minus a off the top of the fraction and divide that over to the other side. So then this will say delta x divided by b minus a is equal to 1 over n. So then in here, I can get rid of that 1 over n and replace it with that delta x over b minus a. But then one more thing that I'm going to do, I'm actually going to take this delta x off of here, and I can put it on the other side of this summation. So then this will say 1 over b minus a, and then we'll have this summation notation starting at this k value of 1 and going up to n of all of these different function values times this delta x. Now this summation notation on the right-hand side should look very, very familiar to us. This is a Riemann sum for our function on the interval from a to b. And as we talked about those Riemann sums, we made a connection between a Riemann sum and an integral of our function from a to b. So we can say that if our function f is integrable on the interval from a to b, then we can say that the average or mean value on that interval from a to b is 1 over b minus a times the integral of our function f of x from a to b. So in this example, we want to go through and actually find the average value of the function f of x equals 4 minus x squared on the interval from 0 to 3. And once we figure out what that average value is, we want to see if our function actually takes on this value at some point within the given interval. So to find our average value, we said we were going to do 1 over the upper limit of our interval, which is 3, minus the lower limit of our interval, which is 0. But then we have to multiply that by the integral from 0 to 3 of our function 4 minus x squared dx. Now, we haven't actually learned how to do these integrals by hand yet, so I'm going to use my calculator to help me evaluate that part. So in my calculator, if I hit math and go down to my numerical integral, I'm going from 0 to 3 of the function 4 minus x squared dx, and I hit enter, and it tells me that value is 3. So I know that this integral value here is 3 times, now this 1 over 3 minus 0, well, 3 minus 0 is just 3, so 1 over 3 times 3, I get an answer of just 1. So the average value of my function along this interval from 0 to 3 is just 1. Now, if we want to figure out if our function actually takes on this value at some point on this interval, what we're going to do is take our function, so the 4 minus x squared, and we're going to set it equal to this answer. Now, going through and solving this, I would subtract this 4 over to the right-hand side. So I would get negative x squared equals negative 3. I'm going to divide both sides by negative 1, so I get x squared equals 3. Square rooting both sides, I'm going to get x equals plus or minus the square root of 3. Now I'm looking on the interval from 0 to 3. Negative root 3 is going to be outside of this interval, but positive root 3 is on this interval. So I know that at an x value of root 3, my function value is going to equal this 1 y value that we were talking about. So we can say that our function does assume its average value in this given interval. That's going to be it for this video. Thanks for watching.